What if one day, without warning, humanity discovered something that instantly redefined its place in the universe? Not a new planet, not a microbe on Mars, not even a distant radio signal repeating a simple pattern, but a structure, something so vast, so unnatural that no natural process could reasonably explain it. A structure surrounding a star, a Dyson Sphere. For most of human history, stars were untouchable. They were gods, symbols, distant fires embedded into myth and religion. Even today, we see stars as unreachable, nuclear furnaces burning far beyond our control. But imagine discovering clear evidence that somewhere in the galaxy, a civilization did not just study a star. They engineered one. The discovery would not begin with drama. There would be no flashing alarms, no sudden revelation. It would begin quietly. A star cataloged decades ago, unremarkable in mass, temperature, and age. Just another data point among billions. Until someone notices something wrong. The star appears dimmer than it should be, not slightly. Significantly, its visible light output is far below expectations. Yet the system is glowing intensely in infrared wavelengths. This is strange, because infrared radiation is heat, and heat, in astronomy, usually means energy being absorbed and emitted. At first, scientists would search for natural explanations: a dense cloud of dust, a protoplanetary disk, an unusual stellar life cycle. But none of the models worked. Dust would scatter light differently. Gas would produce spectral lines that aren't there. A dying star would behave inconsistently over time, but this system remains stable, quiet, precisely balanced, and that is where the unease begins. Nature is chaotic. Stars flicker. Disks collapse. Gas clouds evolve, but this star's energy output appears controlled, regulated, almost managed. The idea of a Dyson sphere enters the discussion, reluctantly, because it sounds absurd. The concept was proposed in 1960 by physicist Freeman Dyson, not as science fiction, but as a logical consequence of exponential technological growth. His reasoning was simple. Any sufficiently advanced civilization will need more energy. Eventually, planets won't be enough. And the most efficient energy source in any system is the star itself. A Dyson sphere, in modern terms, is not a solid shell. A rigid sphere would be gravitationally unstable and structurally impossible. Instead, scientists imagine a Dyson swarm, a vast collection of solar harvesting structures, each orbiting independently, together capturing a significant fraction of a star's output. Even a partial swarm could generate more energy than billions of Earths combined. To put this into perspective, the Sun produces roughly 3.8 times 10 watts of power. Human civilization consumes about 210 watts. That's not even a rounding error. A civilization capable of building a Dyson sphere would operate on an energy scale so far beyond ours that our entire planet would barely register on their charts. As observations continue, the data becomes impossible to ignore. The infrared emission follows a near-perfect black-body curve at temperatures consistent with large artificial collectors. No chemical signatures, no randomness, no signs of natural turbulence. Just waste heat, the unavoidable byproduct of energy use. And that is the most disturbing realization. This is not a message, not a beacon, not an attempt at communication. This is simply infrastructure. Like stumbling across a city from orbit because its lights glow at night, not because it wants to be seen, but because it exists. When the discovery becomes public, the reaction is immediate, and global news spreads faster than comprehension. Social media fills with speculation. Governments issue cautious statements. Scientists urge restraint, verification, patience. But deep down, everyone understands the same thing. This is not about aliens. This is about scale, because if a civilization once surrounded a star with machines, they solve problems we haven't even fully defined yet. Resource scarcity, long-term stability, technological self-destruction. They cross thresholds that may destroy most intelligent species, and they did it long enough ago for their megastructure to still be visible across interstellar distances, which leads to a far more unsettling question. If such a civilization existed, why is the system silent? There are no radio transmissions, no laser pulses, no artificial signals directed outward, just the steady, indifferent glow of heat. This suggests something profound. Either the civilization no longer exists, or it exists in a way that does not include us. For the first time, humanity is forced to confront a humbling idea. Intelligence does not guarantee curiosity. Power does not require communication. And the universe may be filled with civilizations that simply never bothered to announce themselves. The discovery of a Dyson Sphere would not feel like first contact. It would feel like walking into an abandoned power station the size of an entire solar system, machines still running, energy still flowing, but no one left to explain why they were built or whether they are truly abandoned at all. Once the initial shock fades, a deeper and more difficult phase begins, because in science, belief is irrelevant. Only evidence matters. Extraordinary claims require extraordinary proof, and a Dyson Sphere would be the most extraordinary claim ever made. So astronomers would begin to dismantle the discovery piece by piece, actively trying to prove themselves wrong. The first step would be elimination. Every known natural explanation must fail. Interstellar dust absorbs light, but dust leaves fingerprints, specific absorption features, and polarization effects. These are missing. Gas clouds emit spectral lines. They fluctuate. They evolve. This system does not. Its output remains stable over years, then decades. Stability at this scale is unnatural. Next comes geometry. Natural structures are messy, but the infrared emission from this star is isotropic, almost perfectly uniform in all directions. That means whatever is absorbing the energy is distributed evenly around the star, not a disk, not a cloud, a surrounding structure. Then comes motion. If a solid shell existed, it would drift, wobble, and collapse. But a swarm behaves differently. Thousands, millions, or billions of independent objects would create small, predictable fluctuations. And those fluctuations appear. Tiny variations in brightness, minute Doppler shifts, orbital resonances that align with no planetary model. This is not random noise. This is architecture. At this point, the question is no longer, could this be artificial? The question becomes, how advanced would a civilization need to be to build this? The answer is unsettling. The mass required to construct even a partial Dyson swarm would likely exceed the total material of all rocky planets in the system. That means planetary. DISASSEMBLY. Mining entire worlds, breaking them down into raw matter, reassembling them in orbit. This is not a civilization that colonized a planet. This is a civilization that redefined its solar system. And yet, even this might not be the end goal. Energy on this scale enables things we can barely imagine. Simulations of entire biospheres. Artificial intelligence operating at planetary scales. Star lifting, extracting matter directly from a star itself. At this level, the star is no longer a natural object. It is a resource. This forces humanity to confront the Kardashev scale in reality, not as a theoretical diagram in a textbook. A Type 1 civilization controls planetary energy. A Type 2 controls stellar energy. A Type 3 controls galactic energy. We are not Type I. We are not even close. And now we are staring at evidence that Type 2 is not hypothetical. It is achievable. But another problem emerges. Time. Stars live for billions of years. Megastructures would not appear overnight. If this Dyson Sphere exists now, its construction may have taken hundreds of thousands or millions of years, which means its builders were stable over timescales far longer than human civilization has existed. This is not just technological superiority. It is cultural endurance. At this point, a darker interpretation begins to circulate. What if this is not a monument to success, but to extinction? A civilization builds a Dyson Sphere, achieves near-limitless energy, and still disappears, not from disaster, not from war, but from transformation. Post-biological evolution becomes a serious discussion. Perhaps the builders abandoned physical form entirely. Perhaps they uploaded themselves into computational substrates powered by the star. In that case, the Dyson Sphere is not empty. It is alive. Just not in any way we recognize. And here, silence becomes meaningful. A civilization that thinks millions of times faster than us might find communication with humans. Pointless. Not hostile. Not dismissive, just irrelevant. The same way we do not attempt conversation with bacteria living near a power plant. Humanity would now face a psychological shift unlike anything in its history. We would no longer ask, are we alone? We would ask, are we early or insignificant? Because the Dyson Sphere is not looking for us. It is not signaling. It is not responding. It simply exists. A quiet confirmation that the universe does not revolve around human attention. At the same time, the discovery would ignite ambition. If someone else did this, then the laws of physics allow it. There is no cosmic rule forbidding civilizations from mastering their stars, which means the future we once reserved for science fiction has just become a technical problem. But there's a final realization far more unsettling than all the rest. We did not find the Dyson Sphere because it wanted to be found. We found it because our technology finally became sensitive enough to notice the waste heat of someone else's energy use, which means this may not be the first, only the first we could see. The universe may already be filled with silent, ancient infrastructures burning steadily in infrared, unconcerned with whether anyone is watching. And now, for the first time, humanity knows where to look. As the reality of the discovery settles in, humanity begins to change in subtle but irreversible ways, not because of fear, not because of panic. But because of comparison. For the first time, we are no longer measuring ourselves against nature, but against another intelligence. Until now, every limit we faced could be blamed on physics. Energy was scarce. Distances were vast. Stars were untouchable. But the Dyson Sphere proves something critical. The universe allows intelligence to climb far higher than we ever assumed. The ceiling was never physics. It was us. This realization forces a shift in long-term thinking. Short political cycles feel meaningless. Generational planning feels insufficient. A civilization capable of building stellar infrastructure must think in centuries, not elections. In millennia, not product cycles. The Dyson Sphere becomes more than a discovery. It becomes a mirror. Scientists begin to ask uncomfortable questions. What kind of society could remain stable long enough to complete such a project? Not just technologically, but psychologically. A single global war would delay it by centuries. A collapse of institutions would make it impossible, which suggests something profound. Advanced civilizations may not be aggressive by default. They may be patient. This directly challenges one of humanity's oldest assumptions, that intelligence naturally leads to conquest. But building a Dyson swarm requires cooperation on a scale far beyond anything achieved through violence. You cannot surround a star with fragments of destroyed civilizations. You need coordination, continuity, shared purpose across generations that will never see the result. And this raises a dangerous idea. If long-term survival selects for calm, stable civilizations, then the universe may not be filled with warriors. It may be filled with engineers. At the same time, the discovery introduces a new anxiety: visibility. The Dyson Sphere was found because it leaked heat. Energy used leaves a signature. And now we understand something. uncomfortable. As humanity grows, we too will become visible. Every satellite, every data center, every fusion reactor. Our planet already glows faintly in infrared. Right now, we are barely detectable, but one day, we may not be. The Dyson Sphere forces us to confront a choice we never had to consider before. Is hiding safer than expanding? Some argue that visibility is inevitable. Any civilization that survives must consume energy, and energy leaves traces. Others argue the opposite, that silence is survival, that the absence of signals from advanced civilizations is not coincidence. But strategy. The Dyson Sphere does not answer this debate. It intensifies it, because it proves that advanced civilizations exist and remain silent anyway. Another realization follows. If a single Dyson Sphere is visible across interstellar space, then it may be only the brightest example of a broader pattern, partial swarms, early megastructures, civilizations in transition. We may be surrounded by technological artifacts we simply haven't learned to recognize yet. The universe may not be empty. We may just be illiterate. This shifts the focus of exploration. The search for life becomes the search for energy anomalies, not radio signals, not messages, but heat, excess infrared radiation where stars should not be dim. Civilizations may not announce themselves, but physics does. And slowly, an unsettling idea emerges. If energy consumption scales with intelligence, then the most advanced civilizations may be the quietest, not because they are weak, but because they are efficient. Minimal waste, minimal leakage, minimal presence. The Dyson Sphere we found may represent a phase. We are catching mid-transition, a brief moment when growth was still visible, which leads to the most profound question of all. What happens after civilization masters stellar energy? Do they expand outward, building spheres around new stars? Or do they turn inward, optimizing, compressing, refining? At some point, growth may stop being external. Perhaps the ultimate civilizations are not galaxy-spanning empires. Perhaps they are compact, silent, and nearly undetectable, dense with computation, rich with experience, invisible to those who don't know exactly what to look for. If so, the Dyson Sphere is not the end. It is the last loud step. For humanity, this reframes the future. Our destiny may not be to fill the galaxy with colonies. It may be to learn restraint. To grow without screaming our presence into the void. To understand that survival at cosmic timescales may require humility as much as power. The Dyson Sphere does not threaten us. It teaches us. It tells us that intelligence can endure, that progress does not guarantee self-destruction, but it also warns us that the universe does not owe us attention, and that becoming advanced may mean becoming quiet. As years pass after the discovery, something unexpected happens. The Dyson Sphere stops being shocking. It becomes normal. Not emotionally, but intellectually. Humanity begins to adapt to the idea that the universe is older, deeper, and more populated with intelligence than we once believed. And with that adaptation comes strategy. The question is no longer, what is it? The question becomes, what do we do now? For the first time in history, humanity has a confirmed example of a technological endpoint that does not involve collapse. This forces a reevaluation of progress itself. Growth for growth's sake suddenly feels primitive. The Dyson Sphere suggests a different goal. Sustainability at cosmic scale. Engineers begin running simulations, not fantasies, real models. Could humanity ever build something similar? The answer is sobering, but not impossible. With fusion, automation, self-replicating machines, and centuries of stability, a partial Dyson swarm lies within the bounds of known physics. Not tomorrow, not in 1,000 years, but not forbiddance. This realization quietly alters global priorities. Energy becomes the central question of civilization. Not oil, not coal, not even fusion. But long-term stellar energy capture, because any civilization that survives long enough must eventually face the same limit. Planets are temporary, Stars are the real foundation. At the same time, fears intensify. If megastructures are possible, then weapons at similar scales may also be possible. Star manipulation is not inherently peaceful. The same technology that captures stellar energy could destabilize a star, could extinguish one. The Dyson Sphere reminds us that advanced technology is always morally neutral. Its intent depends entirely on who controls it. This introduces a new kind of cosmic caution. Humanity realizes it is no longer preparing only for natural disasters. It is preparing for unknown intelligence, not enemies. Not allies, but actors with capabilities far beyond our comprehension. And yet, no threat appears. No probes arrive. No signals follow. The Dyson Sphere remains silent, which forces another realization. Perhaps advanced civilizations do not expand aggressively because expansion is inefficient. Why conquer stars when computation can be optimized locally? Why spread outward when inward complexity offers infinite depth? This challenges humanity's most cherished science fiction narratives. No galactic empires. No endless wars among the stars. Just isolated islands of extreme intelligence, each minding its own cosmic business. The universe, it seems, may favor patience over dominance. As this idea sinks in, humanity's self-image shifts again. We stop imagining ourselves as future conquerors of the galaxy. We begin to see ourselves as something else. Apprentices. A young civilization studying the artifacts of an older one. The Dyson Sphere becomes a reference point, a silent benchmark. Not saying follow me and not saying stay away, just existing. A reminder that intelligence can grow far beyond its origins without announcing itself to the cosmos. And slowly, one final anxiety takes shape. If advanced civilizations tend toward silence, then the universe may be filled with watchers. Not observers in a dramatic sense, but intelligences capable of noticing us long before we notice them. The Dyson Sphere might not be evidence of attention. It might be evidence of indifference. This thought humbles humanity more than any previous discovery, because it means we are not special for being noticed. We are special only to ourselves. And the universe has always been like this. We just didn't know. In the end, the Dyson Sphere does not answer our questions. It replaces them. For centuries, humanity looked outward and asked whether we were alone. Now the question changes. Not are we alone, but how many civilizations reach maturity without ever being seen? The Dyson Sphere suggests that survival is not about being loud. It is about lasting. This realization reshapes the meaning of progress. Perhaps the goal of intelligence is not expansion without limit, but balance. Not domination of nature, but alignment with it. A civilization capable of enclosing a star must understand it deeply, not as an enemy. Not as a god, but as a system to be worked with, not against. The Dyson Sphere is not a miracle. It is the consequence of patience, planning, and restraint applied over timescales humans struggle to imagine, which means its greatest lesson is not technological. It is cultural. Humanity begins to understand that the real challenge ahead is not reaching the stars. It is surviving ourselves long enough to deserve them. Every collapse in our history now feels smaller. Every war feels shorter. Every crisis feels solvable, because somewhere in the galaxy, proof exists that intelligence can persist. And yet, the silence remains. The Dyson Sphere does not reach out. It does not warn us. It does not guide us. It does not judge us. It simply continues to collect energy, cycle heat, and obey the laws of physics. As if to say, the universe does not care who you are, only what you can sustain. For humanity, this is both comforting and terrifying. Comforting, because it means survival is possible. Terrifying, because no one is coming to save us. No ancient guardians. No cosmic mentors. Just examples. The Dyson Sphere becomes one such example, a silent demonstration that intelligence, when disciplined enough, can transcend its planet without destroying itself, but it also shows us something else, that meaning is not guaranteed by scale. A civilization may harness a star and still choose silence, perhaps. That is the final lesson. The universe does not reward intelligence with purpose. Purpose must be chosen. And so, when humanity looks at the dim star glowing softly in infrared, we are not looking at aliens, we are looking at a possible future. Not a destiny, not a promise, a possibility, one path among many, a reminder that the universe allows greatness, but does not require it, and that if we ever build something similar, surrounding our own star with machines and light, the most important question will not be whether we can do it, but who we become while trying, because in a universe filled with silent stars and quiet megastructures, the rarest thing is not intelligence. It is wisdom.